Alrighty, folks. Today we're talking about predicting. We're talking about telling the future. That's exactly what predicting is. So we want to be able to say by the end of today that I can draw lines of fit for sets of data to help us to predict things in the future based on current trends. This is used in business. It's used in real estate. It's used in investing. It's used in all sorts of statistics in any field that you can imagine. Okay, we're talking about medicine. We're talking about any field you can think of. Okay, we also want to say I can use my line of fit to make predictions about data. This is why it's used, because we can then make predictions. A prediction is not something that is going to happen for sure, but a prediction is saying, hey, this is what I've been noticing. I'm going to make an educated guess. I think this might happen in the future. So, in real life data, hopefully you guys know that points graphed, they usually do not form a perfectly straight line. However, sometimes data does fall into an almost perfectly straight line, okay? And we say that this data approximates a linear relationship. We use the word approximates because, like I said, it's not a perfectly straight line, but when you graph it, if it's pretty close, we say it's approximately a linear relationship. Now, a line of fit, this is the most important thing right here of the day. A line of fit is a line that is very close to most of the data points and can be used to show such a relationship. So basically, if you look at number one, we're going to graph all this data that we have. We're going to graph each of these ordered pairs on our graph. Actually, I've already done so. And we're going to draw a line through the center of all the data. Okay, and that line is going to be called the line of fit, or sometimes you'll see it's called the line of best fit. It's as close as possible to each of the points. It's not allowed to curve. It's not allowed to bend. It has to be a perfectly straight line. So if the data is not perfectly linear, it's not going to touch every single point. But you want to draw it as close to through the center as you can. So with that being said, number one says, the table shows the amount of land in U.S. farms from 1980 to 2000. If you need to take the time here, part A says, make a scatter plot and draw a line of fit for the data. If you need to take a second here to pause the video to graph all of this, okay, do it. Then turn it back on and listen to what I have to say, because it's more important that you understand what's being said than you just copying things down. Okay. So to make a scatter plot, we've got each of our ordered pairs here. On our x-axis, we better label it years, okay, because these are each of our x values. And on our y-axis, we better label it land, okay, but that's millions of acres. That's a lot of land. Now let's just graph each of these points. 1980, 1039, or 1039 is going to be about right here, okay? And 1985, 1012 is going to be about right where my pencil is now. And 1990, let's go over to 90, and then up to 986 is approximately right here. And then 1995, let's go over that, and let's go up to 963. Once again, this is approximate. And then over to 2000, and it's about at 943. So yes, I'm well aware that you don't have this line here yet. That's quite all right. You should have all these points graphed though. Now, if you'll notice, they're not actually in a perfectly straight line. That's okay. Our line of best fit is meant to be as close to all of them as possible. I am suggesting to you that you pick two of the points that are in this grouping, and you make sure that your line goes directly through two of them. You're doing that on purpose. I'll explain why later. Try and pick 2 points that when you draw the line through it, it's going to keep the line very close to all the other points. So I picked our first point and this point right here, 2,943. Okay? And we're going to use that in our next example. So make a scatter plot and draw the line of fit. You have done that. It's got to be a line that's as close as possible to each of those. Now use this line of data, this line of fit, to predict the amount of land in the year 2010. Okay, we don't know anything past the year 2000, but statisticians collected data from 1980 until 2000, and this is what they have. So we're going to try to make a prediction based on what we have. If this trend continues, because you can see the general trend is that this is going down at a pretty constant rate, okay, the amount of farmland that we have. If we try to predict, the amount of farmland in the U.S. in the year 2010, yes, I'm well aware that has passed. We have to bring our pencil all the way to where our line crosses the year 2010, which is about right here. So once again, since we're estimating, we're predicting, we're going to use nice round numbers. What is the ordered pair at which our line of best fit crosses 2010? The ordered pair is 2010, comma, 900. Okay, that 900 is the important thing, because the question asks us, use the line to predict the amount of land. In 2010, there will be about 900 what? Well, you need to look at the units, and since land is measured in millions of acres, you should be able to predict, oh, there will be about 900 million acres of farmland left over in the U.S. if we continue misplacing it, misusing it, and selling it for other purposes. So about 900 million acres. So that's your answer. It's a prediction. Okay? It's where our line intersects the year 2010. Now let's bump on down to our next example. Number 2, same thing. If you need to expand your graph and write these numbers in that I already have written, pause the video, take a second, write it all in, turn me back on, and we can talk. Okay, it says the scatter plot shows the number of U.S. households in millions, so that's a very large number, that have internet access. And once again, we only have data. People have only collected the data up through the year 2000. Okay, so these points were put on the graph for us. And it says write an equation in slope-intercept form for the line of fit. Okay. Well, we all know that in order to write an equation, we need two things, the slope and the y-intercept. The best way to find the slope is after you've drawn your line of fit, okay? But remember, like in the first example I said, please try to pick 2 points that you can draw your line through, and you're doing that on purpose. Obviously, the line has to stay close to your other points. I drew it through my first 2 points here on purpose because now it's going to make it very easy for me to find the slope. So let's do that. Since I have 1996 and 15, and I also have 1995 and 10, I can find the slope pretty easily using 2 points. I'm going to do it up here. Oh, actually, I already have this written in, so I'm going to say y2 is 15 and y1 is 10. So 15 minus 10 divided by x2 is 96 and x1 is 95. Okay, so let's simplify this guy, and it's 5 over 1 for our slope, or just 5. Now that we have our slope, we can't just look at this and say, hey, we know exactly what our y-intercept is. But we learned the other day that if you know a point on your line and you know your slope, you have everything except your y-intercept. Because if you remember, y equals mx plus b is our slope-intercept form of a line. Since we know our slope, we can plug that in for m. And since we have a bunch of ordered pairs that are technically on our line, we can choose one of our ordered pairs. It does not matter which one. I'm going to choose the first one, 1995 and 10. And I'm going to plug 1995 in for x. So that's 5 times 1995. And I'm going to plug in 10 for y. And of course, we don't know b yet. We don't know the y-intercept. That's what we're trying to find. So that's the only variable that we don't know, which makes it easy for us to solve this equation. Okay, so first thing you need to do is figure out 1995 times 5. So let's simplify this a little bit. 10 equals 9,975 plus b. Now, all you have to do to solve for b is get rid of this guy right here. So let's subtract 9,975 from both sides. And you should be left with b on its own over here. And it should be equal to negative 9,965. Negative 9,965. So, now you can write your equation because we know our slope and our y-intercept. Y equals 5x minus 9,965. Remember, this is really 5 million because we're talking in millions. But this is the perfect equation right here. And once again, it is a prediction. So you could be slightly off from me. Now, it says predict the number of U.S. households that will have internet in the year 2014. This is not all that difficult once we have an equation. Since years are on the x-axis, if we're talking about year 2014, we can plug that in for our x, and it's going to spit out a y value. So 5 times 2014 minus 9,965 is going to give us our y value, or our number of U.S. households that we think are going to have internet by the year 2014. This is a prediction. So all you have to do is some quick calculations. 2014 times 5 is 10,070. Then you just have to subtract. And you end up with 105 as your answer, but you have to think about it. Since we're talking in millions, your final answer needs to be about 105 million U.S. households will have internet access. And once again, this is only a prediction. It doesn't mean that it's going to happen for sure. It could be more than this, could be less than this, could be exactly on. But we're trying to take current trends, or at least they were back in 2000, and trying to make an educated guess, an educated prediction. Okay? Alright, folks, not too bad of a day. Rewind me, pause me, do whatever you need to do. I'll see you tomorrow.